Okay, the first video I made, I think I found the main problem with that video, and it was that I had not made a plan at all. So now I've written down what I am, what subjects I'm going to talk about, and I've also placed all the parts for my engine here. So maybe this one will be a little bit more interesting, I hope. First, the cases. As I mentioned in my in the first video, my engine is homemade. Here you can see the case halves. They are milled from two pieces of aluminium, two big chunks, and basically what I've done is milling out the all the critical measurements have been milled in a mill, so that's not too critical, but wait, like that. The diameter for the crank webs in both pieces here, and the diameter for the bearings and the seals have all been done in a mill. Then all the ports and the intake and all the shaping of the flow inside the crankcase was done with a cheap Dremel knockoff. I used 2 evenings, maybe I don't know, 8 hours total in doing that, and this case was originally meant to be used with Speedfight cylinders, Speedfight 2 cylinders. Don't know why I did that. I had a Speedfight cylinder, but it's not exactly the best of choice for the aftermarket tuning cylinders or racing cylinders or whatever you want to call them. There's not too much available for the Speedfight series, and so what I've done what I should have done if I hadn't found this cylinder, I should have maybe made it a whole pattern for Derby cylinders, because there's a lot of options for Derby. But then I came across this, which I will talk about later in this video. But this has a cylinder stud pattern of 57 millimeters squared. So what I did was I epoxied in some aluminium threaded rods in the stud pattern, which was 50 times 48 or something for the Speedfight, and then I milled the top flat, or the deck, the cylinder mating surface flat, so I could fit this cylinder. I also had to epoxy the big transfers on each side, because this cylinder has much smaller transfers than the Speedfight cylinder I was originally using on this engine block had. So that's that. Here's the cylinder side of the rotary valve. The intake was done with a Dremel, and this relief slots they're there for less what do you call it, less rubbing or less resistance. When something for something that's rotating and there's resistance, you call that friction, less friction. They are there for to make less friction. And yeah, I did them in my drill press, and it was not running, but I made an attachment with my Dremel so I could rotate it around and then lower it slowly to make these grooves deeper. Yep. There's 5 8mm studs or bolts pulling the case together, and there's 2 location pins here, so it's in correct alignment. The epoxy I used, I can't really remember. Wait a minute, I'll check it. It was something called Coro Protect epoxy stick, meant for fixing gas tanks, and it seems to be holding up quite well. I've had a lot of experience with epoxy falling off or starting to leak, and some of you may have read my posts on Moped Army when I was originally when I read my attempts at epoxying up cases, stock SPX cases, for running speed fight cylinders. And there was quite a few failures. Okay, that's the cases. Now the cylinder that I've modified this case to run with. It's an IAME cylinder from IAME Parilla, I think the company is called, for pocket bikes. 50cc, 40mm bore, and originally meant for 39.4mm stroke, but my crank is 39.1mm. And what I've done to this cylinder is, if I can remember correctly, I've taken 0.5mm off the top surface, and I've raised the exhaust port. Let's see, get some view in there. I raised the exhaust port, both the main port and the auxiliary ports, and I also beveled the top edge. I don't know if you can see it in there, but there's a large radius on the top exhaust edge to help flow and also to help the piston ring. Not that important with this because it's not that wide, but it's mostly there to assist flow at blowdown. I've rounded off the cylinder transfer interface here, as you can see. That's also to aid flow into the transfers. And else this cylinder is the transfers are stock, not touched at all, and the combustion chamber is also stock. So I've only touched the exhaust and decked the surface between the top and the cylinder. As it is now, the transfers sit, I think it's about 0.2 or 3, I can't remember, but 0.3mm off. The piston moves 0.3mm below the transfers at the bottom dead center. So I should, for best cooling and best flow, I should lower the transfer floors a little bit. That'll come sooner. That'll come later. I'll do that later. My main concern now is just to get it running right. The piston is a body kit piston, 0.8 millimeters, 0.8 millimeter piston ring. Nothing special about it. It's meant for Kreidler van Veen, and the ring locating pin is 90 or 180 degrees from the exhaust port, so it travels centered across the rear transfer port. And that's good, because then as the ring gets pushed back into the bore when passing over the exhaust port, both the ring ends hit that pin at the same time, and with roughly the same time and with roughly the same force. So it isn't hammering on one side all the time, which may cause it to break loose or maybe get not worn down, but break loose. So that's the best way to do it. Straight opposite from the exhaust port. And I know a lot of people have thought that it's a problem to run the ring gap across a transfer port, but it's really no problem at all. It's a problem if you try to run it across a very wide transfer, or if you run the gap at the edge of a transfer, so there's a lot of overhang from so one of the ring ends is hanging a lot over the port, but with a small port and not so much overhang, it's no problem at all. It's better than running it on one of the sides of the ports. Okay, I won't bother with undoing the head. It's nothing special there. One O-ring to seal the chamber and one to seal the water from spilling out. Nothing special. Or it is kind of special. The water flow is very good in this cylinder. First of all, it's perfect for my application, because one of the water inlets, or one of 3 water inlets that I can use, is positioned in the rear, and as I'm running this engine upside down, I won't get an air pocket, and I won't have to drill a hole and make a bleed like I did on a speed fight cylinder. And here it is self-bleeding, so no air pockets. Perfect. And the way the head is designed, or the insert, the combustion chamber insert is designed, the water flows in here, and there's a blocking plate about here, and then the water flows in here, across the transfers, around the exhaust, then up into the head, and then across the combustion chamber, along and over the squish pan, and then it goes out and into the radiator. So instead of just there's a lot of typically moped cooling, moped heads, moped cylinders and heads. There's just a big space and the water is flowing in and out at a random. But here it's flowing in over the transfers, across the exhaust, and then across the combustion or up into the head, around the combustion chamber, and then out. So very good cooling. Well made. Good on you. Aye, Amy. Let's see. All those sounds I'm making, it's I don't know if that's normal in other languages, but in Norwegian it's very typical to, when you're thinking but are going to talk, or you're talking, then you have to think a bit about what you're going to say, It's very common to hang on the words and then continue talking. So if it sounds weird, that's normal in Norwegian. And then it when I'm trying to talk English, I do it also, or I also do it when I talk English. It's not so easy to. It's hard to not do it. If it sounds weird, I don't know. Anyway, here's the rotary valve cover. It's from an Suzuki TS 100, TS 100, 100, 100. What I've done here is I've cut the intake. I've epoxied or pressed on with some epoxy glue around and inside the bore a rubber mount, rubber spigot mount, and I also enlarged the port some from original. It was square originally, but I've enlarged the top of it and also the sides a little bit. And I've blanked off this hole with epoxy and a plate, because as I've cut my crank and I'm not running any ignition or flywheel or anything out there, I don't need the crank protruding here, and thereby I can I have one less seal to worry about. Yep, here's the valve. It's cut a little bit from original, and yeah, it's not much to say about it. Original Suzuki TS 100, TS, that's Norwegian. TS, sounds the same. TS 100, original TS 100 valve, just cut a little bit to get the durations I wanted. Here's the adapter I've made for the crank to fit this rotary valve, and it's made of a steel cylinder, which I've welded 6 3mm pins to the outside, or I've drilled or milled 6 half holes, or I don't know what you call it, but what I essentially did was first drill the 6 holes, then mill off the outside, so the holes were cut in half, and this is how it fits in the valve, or doesn't fit, it seems. There. So that's how it's driven. Doesn't look it looks a bit shabby now, because well, how it's mounted on my crank is with a set screw and that divot there, but in the stock crank I had used kind of a I don't know what you call it. It's a threaded keyway with half the thread in that adapter and half the thread in the crank. Yeah. Okay. Here's the ignition rotor. It sits behind the variator, like this. No, like this, and the variator is on the outside. That's the hole sensor pickup. Had a belt that derailed and was chewed away some of that pickup, but luckily it wasn't damaged. But I'm taping over it now just to be on the safe side. Should maybe make some kind of shield or something That would have been better. That will be better, and I'll do that. So just I just turned this on my neighbor's lathe and drill a small hole and pressed in the magnet that the hole sensor is picking up. So nothing special. The crank. This crank was it's a Doppler endurance crank. Supposed to be the best crank out there for the Peugeot SPX. It might be of very high quality. It seems to be of high quality, but it has one big problem, and that's the balance factor. Because how this came out of the box, it had a balance factor of less than 25%, may have been even as low as 15%, and that made the engine shake a lot. So what I had to do, and what I have to do even more. What I have done is remove, because originally there was some aluminium slugs pressed in this balance holes, and I drilled out those, and that didn't help much. So I ground away the material on both sides of the crank pin here. Ground it to be level, or almost level, with the face that the thrust washers are riding on, and that gave me a balance factor of 38%. I don't want to remove more material here, and I need to bring it up to about 60%. So what I will have to do now is drill a couple of holes here and press in some tungsten slugs to get it up, because I get it up to 60%, because I need 24-25 grams more on this side of the crank. And when I drill out the steel, I'm losing about 30 grams, because there's 14 millimeters, so 2 10mm holes in each web, and they are 14 millimeters thick. So when I drill it out the steel, I will lose about 30 grams. But the tungsten slugs I'm gonna use, which I was tipped by Husaberg on Kiwi Biker, and he provided some links, or gave me the idea of searching for the derby racing cars, though, you know, those gravity toy cars, and tungsten weight slugs for those cars. So and the standard size for those are one of the standard sizes are 9.5 millimeters diameter and 11 millimeters long. And if I drill 2 10mm holes in each web, which is 14 millimeters thick, and press in or glue in, or whatever fits, glue in one slug in each hole, I will get about 24.5 millimeters more weight in the counterbalance end of the crank, and it will bring me up to 60%. And I hope that will solve the vibration issues I've been having, and the fuel overflowing from the carb, because of the fuel foaming in the float bowl. Yes. Okay, that's about it. Yeah, here's the Doppler crank, which I'm using now. The reason I'm not using the stock crank is because the conrod, the small end on the conrod is slightly out of round, and it's pinching the bearings. So what I could do was split it and switch or change out the conrod. But I thought, and that's probably true too, that the bearings in this crank are better, and also It should be, or it's supposed to be, of higher quality steel, and the lighter conrod. The conrod is supposed to be lighter, and it is a little bit lighter too. The small end of it, anyways. But yeah, the stock crank. I lost it. The stock crank has a balance factor of 55%, which is totally okay. And you can see how they achieve that by milling out or casting the webs with large pockets here. But that also makes the crank weak around the big end. So that's also one of the points, one of the reasons I switched to this crank, which I thought would have a better balance factor than less than 15% or less than 25%. But I'll just have to modify it and see if it works. And maybe if it works good, I'll next time I need a new crank, I'll buy one of the stock replacements, because that should work better out of the box. Yep, that's about it. Hope you enjoyed this video a little bit more than the last one. If you didn't enjoy the last one, maybe you did, maybe that was better, I don't know. Maybe leave a comment below and tell me what you think, what you want, if this was okay, or if you want something else, or if I should quit drinking rum while doing the videos, or drink more rum. Maybe that's preferable, I don't know. Maybe red wine or beer instead. Next time I think I will be making a video, or the next episode will be about, I think, about my the rest of the bike, or about the dyno I built. We'll see. So stay tuned.